quick response with reactive capacity. So an intermediate solution, right, between the two extremes of make to stock, single order, and make to order, right, where we only produce or deliver after demand has occurred. An intermediate approach is to use reactive capacity. And we are going to consider here one example. Again, we're going to focus on O'Neill's product, Hammer Wetsuit, right? But the updated timeline will have some reactive capacity. So this time, as before, we have to generate a demand forecast way before the season, right, begins. We have to submit, but we submit only the first order to the supplier. And then when we receive the first order at the beginning of the season, 2 months after the selling season starts, we actually look at what was the demand in those first 2 months, and then based on this, we have an opportunity to submit another second order after those 2 months. So at the end of March, we can submit an order and we can receive it at the end of April, 1 month later. So this is the reactive capacity we have. We have a second order opportunity, right? And so in the second part of the season, we have potentially an additional quantity that we order in the second order opportunity. And it might be that we order 0 here, or it might be that we order some positive quantity, right? And we might still have leftover units. So the parameters are as before. The demand, right, has we created a forecast which is represented by demand distribution, normal distribution function with mean and standard deviation as shown here. We also have the price, cost, and salvage value as before, 190, 110, and $90 of salvage value. And one more new thing is that in the second order, the cost is no longer $110 per unit. It is 20% higher. So we pay a premium for this reactive capacity, for this quick response, right? This delivery time will be just 1 month. We pay $132 per unit, which is 20% higher than the original cost. So some assumptions we're going to make here in order to be able to evaluate this and learn something from this example, have some managerial insights. So the assumptions will be there is no restriction on the second order quantity, right? We don't put a maximum limit here. Another restriction or assumption is that there will be no shortage before the second order arrives, right? So that means that the first order will be reasonably large and it will be sufficient, right? So if you go back, right, the first order which we receive here should last us at least for half the season, right? At least with a close to 100% likelihood, right? And the third assumption is that the forecast of total demand will become perfect after observing initial sales. So what I mean by this is that at this point, after the first 2 months of sales, our forecast is no longer uncertain. It is we know exactly how much more we will sell in the remaining 4 months, and if we don't have enough units, we will exactly order whatever is necessary in the second order quantity for the remainder, right? So if we have low demand and maybe we already have too many units, then we will order 0 here and receive 0. But if we expect demand to be larger than our initial first order quantity, we will just order exactly the amount that we need to cover the demand. And so there should be no lost sales in this case. So the solution is actually going to be obtained using the news vendor model, but slightly modified. So consider this. If the first order is too low, right, then in the second order, we know exactly what is needed to be, right, to cover all the demand. So let's say if we decide to order the first quantity 2,000, and then after observing the first 2 months, we see that the total demand for the season will be 4,000, then the second order will be exactly another 2,000, right, to cover the demand exactly, right? So the cost per unit of ordering too few units, that I mean ordering in the first order opportunity, is not going to be a lost sale, so lost profit from, right? The units that we wouldn't sell in this case, but it will be the premium that we pay, right, in the extra cost that we pay in the second order. So in other words, if you don't order enough in the first order opportunity, then in the second order opportunity, you order at a 20% higher cost, which means you have a $22 underage cost, right? And notice this is different than before. Before we had $80 underage cost, and it meant that we will have lost sales, and every unit of lost sales is like lost opportunity to make $80. Whereas now, if we order too few units in the first order, then the only cost is the premium we have to pay to order those missing units in order to cover the total demand, right? The average cost still remains the same. So if the first order is too high for the whole season, we will have leftover inventory, and each unit of leftover inventory will cost us $20. So what I want you to see is that now that we have updated our underage cost, right, we can calculate a new critical ratio. It ends up being much smaller. It was 0.8 before, now it's 0.52. And we can calculate as before, right, the quantity Q as inverse of the cumulative distribution function of the normal distribution, right, with our mean and standard deviation. You can do this in Excel using the norm in function, and you find out the first order quantity is 3,262. But remember, this is just the first order in this case, and we will have a second order opportunity. So if we now evaluate the three performance metrics from the news vendor model, expected lost sales, and expected leftover, assuming the order quantity Q, right, which Q means now the first order quantity, and right, and then remember we are assuming that the underage cost is now $22, right? We will get expected lost sales 436.5, expected sales 2,755, and expected leftover 507.5. However, we shouldn't understand them the same way as before, because remember, in this new case, if you have shortage, we really don't have a shortage, right? So lost sales will not exist. In fact, what we see as expected lost sales in the news vendor model is actually what we should order in the second order opportunity, right? So 436.5 is the expected quantity that we will order in the second order opportunity. Now, notice this is just an expected value. We really don't know how much we will order ahead of time. We have to observe this first 2 months of demand, and then we will know how much we will order. We might order 0, we might order some positive value, maybe even 1,000 units, right? On average, the expected value of that second order is 436 units, 0.5. So in fact, there won't be no lost sales, right? Now we really have no lost sales, right? What is seen as expected lost sales in the news vendor model is in fact the second order quantity, its expected value. So expected sales, right? There won't be lost sales. So expected sales will be news vendors' expected sales, and this expected second order quantity, which is news vendors' lost sales. So in fact, if you add them, they will actually, the expected sales will be equal to mu. We will actually have no lost sales. We will sell on average what the demand says, right? Expected lost sales will be 0. But expected leftover still remains. It is still as in the news vendor model, so there is no change here. Expected leftover is news vendors expected leftover, right? And it's much smaller than we had before in our model with a single order opportunity that we considered in the previous topic. Now, if you consider a maximum profit, it is the same as before, right? With a perfect forecast, we could expect to have this much profit. Now we can calculate a mismatch cost, and the mismatch cost, again, we calculated the same using the same formula. Just remember that the second part is not expected lost sales times U, it's expected second order quantity for which we pay extra $22 per unit, right? So now the mismatch cost is 19,753, and it is considerably less than 33,000 that we had before with a single order opportunity. And of course, expected profit, which can be calculated as maximum profit minus the mismatch cost, is now higher than before. It's 235,000 and a half and 607 compared to 222,297. So to summarize, right, when we had just one order opportunity, we decided to order 4,186. And if we have two order opportunities, the first order is smaller, right, roughly 900 units smaller, and then the expected value for the second order is around 436.5, right? Expected sales are improving now. We will satisfy all the demand. We will have no lost sales, right? Um, uh, so expected lost sales becomes zero. Expected leftover is lower, right? Also by about 55%. But what is most important is that mismatch cost has decreased by around 40%. Or if you like, we can look at the profit, and expected profit has just increased by about 6%. So as you can see, reactive capacity can provide benefit even if we pay a premium on the second order opportunity, or we could have a third or fourth order opportunity, right? Even if it is more expensive to deliver this order at an accelerated time with a shorter lead time, still it can provide us with significant increase in profits, expected profits, or it can reduce actually a lot, right? The mismatch costs that we experience.